Hi, here we have a question about redox, and it's quite tricky, and I'll explain why. So we're going to do 2A part 1 and also do the half equations here. So the tin nitric acid one you can do on your own using the example that I'm going to do here. So we're looking at this one. Why is that tricky? Well, there's two reasons why it's tricky. One is that it's disproportionation. It's disproportionation. You can see the chlorine, elemental chlorine, going not only to chlorate and also to chloride. Okay, so the oxidation number of the chlorine in chlorate is going to be +5. Work that out if you like, and very quickly you can see that the oxidation number of the chloride ion in sodium chloride is -1, and of course this is elemental, so that's oxidation number 0. So you can see the one reactant has both been oxidized and reduced. Oxidized to chloride, reduced to chloride, and oxidized to the chlorine in chlorate. Okay, so that's disproportionation makes it a little bit tricky. The other thing that makes it tricky is the fact that it's in alkali conditions. It's in alkali conditions, and pretty much all the examples you've done are either neutral conditions or acid conditions, and the spec is vague on whether it requires you to learn about half equations in alkali conditions. It doesn't say one way or the other, but when you check exam questions, they're pretty much all. I can't even remember seeing an exam question in alkali conditions. But it's not impossible that you get one, so here we're going to learn how to do them. And it's actually only one further step over our normal process of balancing half equations. Okay, so let's first of all balance this equation. So in order to balance this equation, we have to look at the oxidation numbers. We've written them out there, and so let's start off with chlorine going to chlorate. Yeah, so there's the chlorate ion, and there's 2 chlorines in a chlorine molecule, so we're going to need 2 chlorate ions. You could do half and 1 if you want. Let's just carry on like this since we've started. But we know that this chlorine is +5, and there are 2 of them, so we must give up 10 electrons in that process. So we're not going to carry on with the rest of the half equation yet, because all we're trying to do is balance the equation at the moment. Of course, part B is write the half equation, so we're going to come back to this and finish off that half equation later. But for now, we're just doing what the question says. We're trying to balance the equation in 2A part 1. Okay, so that is the oxidation reaction. Now, chlorine also takes part in a reduction reaction, and it makes chloride ions, doesn't it? And so, if we've got 2 atoms of chlorine in the molecule, we need 2 chloride ions. In order to make those 2 chloride ions, this chlorine molecule needs to gain 2 electrons, like so. All right, so in fact, there's a whole half equation. We no further work to do on that one. However, let's carry on with the job at hand, which is to balance that equation. So what we're going to do now is notice that we've got 10 electrons on the top equation and 2 electrons on the bottom equation, in which case if we multiplied this by 5 and then change colour, we would be able to cancel out the electrons. So this becomes 5, that becomes 10, and this becomes 10 as well. Then we would add them together when we look at the full equation. So let's do that. So then you would have 6 chlorines. Right, the electrons have cancelled out. Let's cancel those electrons and those electrons. You'd have 6 chlorines, and that's it for the left-hand side. On the right-hand side, we've got 2 chlorates. I'm leaving a little gap there. And I won't put my charge in there because now we're going to the full equation. We're going to add back in our sodium. So there's our sodium chloride, and then we've got 10 chlorides here. Right, so in the same way, I'm going to add back in the sodium there, like so, and miss off the charge of that chloride ion there. And then all we have to do is balance our reaction. But we've got sodium hydroxide here, and let's count up our sodiums. We've got 10 in sodium chloride and we've got 2 in sodium chlorate, so that's 12. So let's put 12 there, and let's see if the oxygens and hydrogens are sorted out. No, they're not. So we need some more water to sort them out, and we've got water in the main equation. So we just need to work out how many balance those waters, and it turns out that if we had 6 waters, that would give us 12 hydrogens, for example, and there's 12 hydrogens in sodium hydroxide, and 12 oxygens are accounted for by 2 times 3 is 6, plus 6 in water is 12. So there we have it, nearly. Okay, so that would probably get the mark if the mark scheme said allow multiples. If it didn't say allow multiples, the examiner would be expecting you to just simplify this, because you can see each of these molar ratios you can divide by 2. So let's do that. So you could have 3Cl2 plus 6 NaOH goes to 1 sodium chloride plus 5 sodium chloride plus 3 waters, and there, that would be our answer to 2A part 1. So quite a few marks for that if it was an exam question, maybe 3 or 4. And then 2B, write the half equation. Okay, so let's start off with, let's change colour and start off with this. We're going to complete that equation there. As it happens, this is the tricky one, and you'll see why. I'll go back to blank. Anyway, we've got chlorine there already. That's good, and leaving space for anything we might need to add to balance stuff. We know we've got 2 chlorate ions there as well. Now, first of all, our atoms are balanced. Our chlorine, non-oxygen hydrogen atoms are balanced with, which is just chlorine in this case. So we've got 2 and 2. Now, let's balance our oxygens. All right, the normal way of balancing oxygens is by adding water, isn't it? However, this case is slightly different because it's alkali, isn't it? Yeah, you can see from the equation, right, all this sodium hydroxide here in the main equation, it's in alkali conditions. So what you do in those conditions is, instead of balancing the oxygens with water, you balance them with hydroxide. Okay, so we're going to add some hydroxide ions instead of water, and we've got 6 oxygen atoms on the right hand side, so let's add 6 hydroxides, like so. Okay, so that's sorted our oxygens out, but unfortunately it's introduced some hydrogens. All right, so normal way of balancing hydrogens with hydrogen ions. Let's do that for now. So we've added 6 hydrogens on the left hand side, so let's say 6 hydrogen ions on the right hand side. We've forgot our 10 electrons. Let's put our 10 electrons back in. That's these 10 electrons here. And so now, here's the thing. If there was hydrogen ions in solution, in an alkaline solution, they wouldn't exist, would they? They would react with hydroxide ions. And this is now a balanced equation from an atom's point of view. Look, we've got 2 chlorines, 2 chlorines, we've got 6 oxygens, 6 oxygens, we've got 6 hydrogens, 6 hydrogens. It's all balanced, right? So if we make any changes to it now, we have to make them to both sides of the equation. But we can't have hydrogen ions in an alkaline situation. So what do? We add more hydroxide ions. So let's just say, and how many hydrogen ions would we react? Well, we react 6, right? So 6, did I say hydrogen ions? We add more hydroxide ions. So we're going to add another 6 hydroxide ions. If we added 6 hydroxide ions to our, do this one in red, to our hydrogen ions, you would get 6 water molecules, right? So that would change into 6 water molecules. And if we added 6 hydrogen ions to the right hand side, we would get 12 hydroxide ions. I'm hearing back my voice in my head, and I'm hearing hydrogen ions instead of hydroxide ions, but hopefully that's been clear. So let's just write out our new equation. You've got Cl2 plus 12 hydroxide ions goes to 2ClO3, that's not changed. And now our 6 hydrogen ions, that's turned into 6 water molecules. And we still have our 10 electrons there. And that is now good. You could take half of each of these, so you get half a Cl2 molecule, 6 hydroxide ions, 1 chlorate ion, 3 water molecules, and 5 electrons. Or you could leave it like this. I'm going to leave it like that. Okay, so that is the half equation for 2A part 1. Let's, for the sake of completeness, do the other half equation. Where did it go? Here it was. But as it happens, it was already fine. So, but we'll write it out anyway. So we've got the 2. We had 5 Cl2. All right, and we had 10 electrons, and that made 10 Cl minus. Like so, and that's our other half equation. So these are our half equations. Like so, and that's the answers to 2A part 1 and 2B part 1. Have a go at 2A part 2. And if you can't do it, let me know, and I'll do another little worked example like this.